25 years ago using Westgard's QC selection grid. The rows of the grid correspond to your method quality. The higher the critical systematic error, the better off the method is. Critical systematic error is the number of SDs the mean can shift before more than 5% of results exceed your error limit. That's where this 5% came into play as the acceptable number of errors. The rows relate to your critical systematic error. How many SDs can the mean shift before you're in trouble? Is it less than 2, 2 to 3, or more than 3? The columns of the grid represent better method stability. If your method stability is excellent, you can use looser QC rules. So here you would use a 1.2.5s rule, here you would use a 1.3s rule, and on the bottom row you would use a 1.3.5. And depending on your method stability and on your method capability, you would pick one of 9 different choices of QC rules. You had the same choices for multi-rules, so you could use this same process to select either single rules or multi-rules. We started with this, and the problem we ran into was it was really very difficult to categorize the stability of your method, at least to begin with. And when you looked at these percentages over time, a poor method, would you ever put up with a method that had more than 10% errors, real errors? Just to take you through the process, this was the original recommendation of the way you would select these rules working with the QC selection grids. You would set a critical decision level, and then you would determine your allowable error at that critical decision level. You would estimate the bias and the SD at that critical decision level. You would use those values to calculate the critical systematic error. Don't worry about the calculation. The number of SDs you can shift before you're in trouble is 3, basically 2.98. You'd go to your QC selection grid. You would pick the middle row because your critical systematic error is between 2 and 3. You would pick the right-hand column because your method stability is excellent, and you would choose a 1.3s rule and for an N of 2. If you were working with the multi-rule options, these are the rules you would choose. You would then go and compare the probability of error detection and the probability of false rejection for each one of them and select your appropriate QC rule. We modified this to put it into practice in a more automated basis because I had 6 labs, all the disciplines, all the QC. So what I did was create a computer program that would do much of this for us. This is how we modified the method for implementation across my 6 labs so that we could handle all of that data for all of those labs in all of those disciplines and eliminate the estimation part of the process. So we measured the current mean, we set a target mean, which was our peer value. So this is a verifiable number, our target mean. The current mean is a verifiable number. We then calculated the bias. We didn't estimate it. We used the usual standard deviation, and we set an allowable error limit at each level of control. We then calculated the critical systematic error for each level of control, went to the row of the grid. Now we have 2 rows to deal with because one critical systematic error is 2.45 on the second row and the other one is greater than 3 on the bottom row. But all the methods were excellent, so for level 1 we chose a 1.3s rule, but level 2, where the method was better, we used a 1.3.5s rule. 25 years ago, we had these processes. 25 years ago, we were presenting posters at AACC about the benefits of doing this. This is how the system was implemented on that wonderful computer and dot matrix printer 25 years ago. Here are 3 of the 6 labs. Each row is a different month. all of the labs had the same target mean, the same true value, and that makes sense because if you took a patient sample and tested it month after month after month, its true value would not change. If you took a patient sample and you send it from one lab to another, its true value would not change. And it's exactly the same for that QC sample. Its true value does not change. We then measured the mean, we used a usual standard deviation, we calculated the critical systematic error, and based on that critical systematic error, we selected the QC rules. So in the same month, each lab was using a different QC rule to match their individual method capability. And over time, labs would change their QC rules as the method got better and worse because let's face it, your means, your SDs change. Whenever they change, it affects your critical systematic error, your margin for error, your sigma, whatever you want to call it. When that changes, you should be changing the QC in response. And we'll end up this week with a reminder that there are 3 critical components to ensuring quality. You need to be able to answer the questions, was the method okay yesterday? How do you know? Did it change significantly today? And would I stop if it failed tomorrow? Those are the 3 questions we will be able to answer by the end of this series. Next week, it's an open dialogue. Send in your Q&A. What are we going to talk about? What would you like to talk about?